All right, let's dive in. Today we're going to talk about something that is absolutely essential to every single app on your phone and computer, but it's something that usually happens completely behind the scenes. We're talking about software testing. We're going to pull back the curtain and see how we keep our digital world from, well, completely falling apart.
So, to really get why testing is so important, you have to understand this one core idea. Building software is nothing like building a bridge. Seriously. When you build a bridge, you have a blueprint, it's based on physics, you build it, and for the most part, it just stands there. It doesn't change. But software? Oh, software is a completely different beast. It's alive.
And this right here is the heart of the problem. Think of any piece of software as being built on this gigantic, ever-growing mountain of other code. These are called abstractions. New features just keep getting piled on top. But here's the catch. No single person on the team, no one, fully understands how every single piece of that mountain works. And that complexity, that's where things get risky. That's where things break.
So how in the world do you manage that kind of complexity? Well, you don't just cross your fingers and hope for the best. You use a disciplined, scientific approach, and we call that testing. It's our systematic way of proving that the code we just wrote actually does what we think it does. Now, when it comes to testing, there are really two main ways to go about it. On one side, you have manual testing. And yeah, it's exactly what it sounds like. A human being literally sits down and clicks every button, fills out every form, trying to break things. It's important, but you can imagine it's super slow and people make mistakes. On the other side, we have the modern solution, automated testing. This is where developers write more code just to test the application's code. It's fast, it's repeatable, and a computer never gets tired or bored.
And this whole automated approach, it has been scientifically proven to work. There's a method called test-driven development. And get this, it's where you write the test before you even write the code that's supposed to pass it. I know, it sounds backwards, but it forces you to think so much more clearly about your design, and the data shows it dramatically reduces bugs. That little bit of extra work up front saves you from so many headaches down the line.
Okay, so we're all in on automation. But what does one of these automated tests actually look like, under the hood? It might sound intimidating, but it's really not. In fact, pretty much every single test follows a really simple 4-step pattern.
Here it is. It's like a recipe. First, you group your tests together into what's called a test suite, which usually describes a whole feature. Step 2, you state the one specific behavior you're checking in this one individual test. 3, you actually run the piece of code you're trying to test. And finally, number 4, the moment of truth, you check the result.
That final step, checking the result, is done with a special line of code called an assertion. An assertion is just a simple true or false question. It asks, hey, did I get the outcome I expected? If the answer is yes, the test passes. Green light. If the answer is no, the test fails. Red light. It's the simple, clear thumbs up or thumbs down for that piece of code.
So who's in charge of all this? What actually runs all these tests? Well, those are special tools called test runners. Think of them as the conductor of the orchestra. They can run all of your tests automatically in the background every time you save a file so you get feedback instantly. And even more importantly, they act as a gatekeeper, running every single test on a server before any new code is allowed to be released to the public.
Okay, so we know how to write a test now, but you can't just write a bunch of tests randomly. You need a strategy. And there's a well-known structure for this, often called the testing pyramid, that breaks everything down into 3 key levels.
At the very bottom of the pyramid, the foundation, we have unit tests. These are laser-focused. They test one tiny granular piece of code, like a single function, all by itself, completely isolated from everything else. For example, does this little function that's supposed to add 2 numbers together actually return the right sum? That's it. Simple, fast, and straight to the point. Now, moving one level up, we get to integration tests. Here, we're not testing things in a vacuum anymore. We're testing the connections. We're asking, do these different pieces of the puzzle actually fit together? Can the user interface component successfully talk to the database service and get the data it needs? We're testing the seams between the different parts of our app. And finally, at the very top of the pyramid, we have end-to-end tests. You can think of these as the final dress rehearsal. An ETE test literally simulates an entire user journey from start to finish. It's like having a robot open a web browser, click on the login button, type in a username and password, and navigate through the app, just like a real person would. It's our robot manual tester, and it works at lightning speed. This chart really shows you the strategy in action.
The idea is to have a whole lot of those small, fast, simple unit tests. They make up the wide base of your pyramid. Then, you have fewer, slightly more complex integration tests. And at the very top, you have just a handful of those big, slow, end-to-end tests that cover your most critical user flows. It's all about getting the most confidence for the least amount of effort.
So, we've covered the anatomy of a test in the 3 main levels. But trust me when I say, the rabbit hole goes so much deeper. We've really only just scratched the surface here.
I mean, there's a whole universe of other specialized types of testing. You've got things like performance testing to see if your app is fast enough under pressure. You've got smoke testing, which is just a super quick check to make sure nothing major is on fire after a new change. The world of testing is honestly huge.
And that really brings us to the final and most important question. With all of these different types and levels of tests, how do you know which one is the right one for the job? Because it's not about doing every kind of test imaginable. It's about picking the right tool. Knowing when to write a simple unit test versus a complex end-to-end test is what really separates good developers from great ones. The goal is always to get the maximum amount of confidence with the minimum amount of work. And that, right there, is the true